Hi, my name is Sasha. Welcome back to Next Gen Coders. Today we're going to be covering all you need to know for Unit 2, Part 1, Strings and Class Types. Now, this is going to be going over all the content that you need to know to pass the exam and the test in May. Okay, so we have two different data types in Java, primitive and reference. Primitive is going to store one piece of data, whereas reference holds multiple pieces of data. And the cool thing about reference data types is that they have built-in methods that we can associate with them, which makes them pretty handy when we're actually coding. For primitive, it's going to be storing the actual value, whereas for reference, it's going to point to where the information is stored. So it's not storing the actual value. And then another thing about reference data types is that they can store null values, which is basically like empty. A good way to identify whether something is primitive or reference is by looking at if it contains a capital letter or not. Primitive always has a lowercase letter, and reference data types always start with a capital letter. So let's do this exercise right here. You can pause it, and then we're going to be going over the answers. So int right here is primitive, integer is reference, and string is reference. Now, for the next slide, we're going to be talking about strings and how they're immutable, so-called. So strings are immutable. As we've gone over before, strings are reference data types, so they're not going to be storing the actual value. So let's take this code right here. So the first line, string x equals hello. We're going to be setting x to hello, but since it's reference, x is not going to be storing the actual value of the string hello. It's going to be pointing instead. Then look at the next line, string y equals x. So instead of y actually pointing to x, it's more going to be pointing directly to what x is actually pointing to as well. So since x is pointing to hello, y is also going to be pointing to hello as well. Then we're going to be looking over here, string x equals bi. So we're going to be changing the direction of the arrow or of x, but that doesn't affect y. So even though x is now pointing to bi, y is still pointing to hello. So y will maintain the value hello. Okay, there's 3 ways to construct a string, and each one works. So for the first one, string x equals hello. Pretty simple. That's how you'll usually want to construct a string when you're coding in Java. Next one, string x. You're setting you're creating a variable called x. Then the next one, you're setting the string x equal to hello. So this is basically step 1, except you're just breaking it off into 2 steps. Whatever makes you comfortable. I think that's this one. The first one is more efficient. It takes up less lines of code, but whatever works for you. And then for 3, this is making an object, and you can tell when you're making an object because there's the new keyword. So just likewise, like the other 2 ways, you can do the same as for the third one. That one will also work, except this one's creating an object. Okay, objects are data types that are like an instance of a class, such as a blueprint, for example. So as I said before, objects are created using the new keyword. For example, regular polygon, that's the class. Circle would be the object. The name of the object, you can call it whatever you want. We have the new keyword, and then we're going to be calling the class again. Then we always want to close it off with the parentheses and the semicolon. So objects are easily distinguishable, and the state is represented by the values in the fields, and methods define the actions the certain object is performing. So as you can see right here, we have this whole block of code. The class is car, okay? And then under the main method, we are calling an object. So we're calling the class car, my car, which is the name of our object, and new, and then calling the class again. Okay, how strings work. Each character of a string is stored individually in memory. Now, each of these kinds of places can be referred to as an index. So each of these characters are given an address. And the addresses begin at 0. You know how when we count, we'll start at 1, 1, 2, 3, 4, 5? No, but for addresses, you're always going to start at 0. So the address of each number is called the index. So let's have an example right here. String x equals computer. This is a string. Then we're going to break off the computer into each thing is going to store one character. So we're going to break it off, COMPUTER. C starts at 0. Remember how I said the adder starts at 0? That's the rule you always want to follow. 0, 1, 2, 3, and up. Okay, concatenation. So we have this right here. Concatenation is basically putting all those kinds of strings together into like a sandwich. So system.out.println, the sum is 2 plus 4. Now you'd think, hey, okay, 2 plus 4, that's easy. That's 6, right? But no. So the result would print the sum is 24 or 24. Okay. So this is because the string comes first. So Java follows the rule that, okay, so I see the string first. I'm going to assume everything else is string. I'm just going to put them together like a sandwich. It's not actually doing the math. Okay, so it's going to print the sum 24. So it's concatenating everything, putting it together. It's not doing the math. But what if we want to make this 6? Well, we're going to put parentheses, right, like next to the 2 and 6, and like put those in between the parentheses because of order of operations, PEMDAS. See, parentheses comes first. Okay, cool. Okay, methods. Strings or even like reference data types, they have built-in methods as we've talked about, I think, on the first slide. So strings have data and tools that we can use to work with the data in these strings. So we have all these kinds of methods, .length, .equals, so on and so forth. We'll be going into them in detail in one of the next slides. Also, we have this one thing, like if you're going to memorize anything, memorize this, the math.random, because you need this for the exam. They're not going to give you a formula chart on this. So my best bet is like to memorize the formula for this, and the formula will be right here. Math.random, okay, that's basically going to pick it's going to choose a random number between 0 and 1, like a double number between 0 and 1, and the exact formula, like if you want to mutate it, if you don't want to just do 0 and 1, let's say I want to do like 0 or like 1 through 6, okay, then you can always, we have a formula for this, so it's basically going to be math.random and of the range, okay, which the range is basically max minus min plus 1, and then outside plus the minimum number that you want to start at. In this case for here, the minimum would be 1, so plus 1. So, yeah. Then we have escape sequences. So escape sequences are used when you want to do any character such as like a quotation mark, because if you're going to be putting 2 consecutive quotation marks, like let's say I want to actually have a quotation mark in my string, but Java's going to notify that as, it's going to notice that as an error because it's going to be asking, hey, why are you putting 2 quotation marks? Are you doing something wrong? Well, obviously not, because like I want to have like another quotation mark inside of the string, but Java doesn't know that. So a way to for Java to distinguish whether it's like an error versus like something that you're actually trying to do is through escape sequences. So basically, if you want to do the double quote, you look at the last one, the backslash, and then the double quotes. So for escape sequences, it's always backslash. So remember that. So backslash n, backslash t, horizontal tab, all those kinds of things. I think the one that you need to know, I don't remember at the top of my head. I think it's backslash n, and then backslash. But yeah, I'm pretty sure. Just like, but even like you don't need to memorize this. I feel like just like doing the coding itself during the course, you'll get the hang of it. You're gonna memorize it either way, but still. Okay, methods. Strings are class data types or reference data types. Class, reference, same. So they have tools that we can use in order to access and manipulate them. Methods are performed on objects. Strings are objects. Wow. Okay, we have an example right here. String A equals string. A dot method. Now we're not actually saying dot method. That's like where we're applying the method. Like for example, do these look familiar? Well, they were on the previous slides. So we're going to be going over them now. So basically you'd say like a dot length, a dot equals, like all that kind of stuff. Okay, first one, a dot length equals 6. Okay, so basically you're just going to find the length of that kind of string. So string, count those, 6 letters, yay. Dot equals. That one's going to be comparing one string to another. Okay? And this one's going to like return a Boolean value. So it's either true or false. So a dot equals string. Now, that's false. But why? Okay, so dot equals is case sensitive. So in case you're doing something in all caps or something like, even if you have like the case is like differing by like even like one single like character, it's gonna mark that as false. It's like case sensitive. Dot index of, it's going to find the index of a character or even like a string in that whole string itself. So a dot index of r, okay? It's going to find the first instance of r in this case. So 0, remember how we started 0? 0, 1, 2. So the answer would be 2. Dot substring, that's going to be finding the substring of starting from any kind of value that you want until the first value you don't want. So the value in the second place, it's going to be exclusive. So it'll be inclusive, exclusive. So a dot substring 3. In this case, we don't have like another value, the first value you don't want. So that's just going to be finding 3, 0, 1, 2, 3, I, and then it's going to be going all the way right until the string's like done. But one thing you want to make sure of is that you're not going out of the boundaries. So if you're doing an index of something like index 100, hey, wait, we don't even have that many characters. It's going to mark that as an out of boundaries exception. So you need to be careful as not to choose like, basically you need to be aware of the index that you're using. 2 dot uppercase, 2 dot lowercase, pretty simple, pretty explanatory. You're just changing it all into uppercase or changing it all lowercase. Dot compare to, that's basically comparing the first string to the second string through lexicographically, I'm pretty sure. But basically what it's going to be doing is it's going to return 0 if the strings are the same, return a negative value if the outside string, which is A, for example, comes before the other string alphabetically, or it's going to return a positive value if the string comes after the other string alphabetically. Okay, that's it. Let me know if you guys have any questions. We always improve like from questions and stuff like that, so if you want, just tell us, or like if you have any ideas or videos that you want us to do, let us know. Thank you.